Alright, so let's say that we're given this triangle and we have one angle, two sides, but we don't have an opposite angle side pair. Right here we're missing our side, we're missing our angles for the other pairs. So that means we have to use the law of cosines. We know the law of cosines looks like this. And when we fill in all of that information, we get this equation right here. This is a nice equation for us because our variable is all on one side. It's not quite isolated yet though. We have to take the square root of both sides to get c by itself. This one is a little bit simpler than some of the other cases when it comes to putting it in our calculator. So let me show you how we would do that. So this one here, we can really just put it all at once. So we're going to hit second square root and just type everything we've got here. 2 squared plus 6 squared, which we can probably do those mentally, but sometimes we're going to have bigger, messier numbers, maybe some unfamiliar decimals, so it's okay to put it in there just like that where we square it. And then now we need to do times the cosine. So for that you hit second pi, which gets you to your trig functions. You can hit the number 2 or use the arrow function here, and then you want to put in your angle measure. And you can just hit enter. So it's all just put in there as one step. Sometimes though it's not quite as simple as that because sometimes we're going to have to find our angle. And when we have to find our angle, our law of cosines, still the same equation, but now we are going to have to use our inverse sign. We know we have to use the inverse sign because we're taking the cosine of a variable. Or sorry, inverse cosine because we're taking the cosine of a variable. So in order to do that, we have to think about how to solve equations. So in this step here, we want to get p by itself. We have to follow our order of operations. We're going to have to subtract the 6 squared and the 4.5 squared before we can do anything else. I could put that in my calculator right away, but then if we get a weird decimal, you know, if our numbers aren't as nice and neat as they are in this problem, then that can cause some rounding issues later. So I'm just going to wait, put it all in my decimal all at once. So now we're looking over here, we're not quite ready to put anything in our calculator because we still have a lot going on the side with our variable. So we can almost ignore this cosine, and if we just had some number times p, we know from way back in pre-algebra that we are going to divide by that number that's being multiplied by p. That's the same for cosine of p. We have some numbers times cosine of p, so we're just going to divide by these numbers. And we get this right here so far. Now we're ready to take the inverse cosine. We're taking the inverse cosine because we want to get rid of the cosine so that p is isolated. So when we take the inverse cosine of this side, it cancels out cosine and we're left with just p. Take the inverse cosine of this side. I forgot. Parenthesis, not that that matters too much. Let's put this in our calculator. So this, again, we can put all at once so we don't have to worry about any rounding errors. So we're going to do second pi to get to our trig functions. We're going to go all the way down to inverse cosine, which happens to be number 5. And then we can put this in pretty simply here, but what I'm going to do is put parentheses around the numerator so that it knows that it's dividing this whole thing by the product down here in the denominator instead of it accidentally dividing just the 4.5 squared by this. So putting parentheses around the numerator to give it the grouping symbols so that your calculator knows what order of operations you're intending to do. So I have to close my parentheses because that was my numerator, and now divide by -2 times 6. I'm going to put parentheses around the denominator as well. I forgot to do that. So I went back. So there's my numerator, close parentheses, divided by my denominator. So -2 times 6 times 4.5. And when I hit enter, I get 99.98. So that they're saying that that angle there must be 99.98 degrees. We could use the converse of the Pythagorean theorem and test it out and make sure that that angle should be an obtuse angle. That would be a good way for you to do a little self-check to make sure you're on the right track.